Hello students, in this video we'll give a proof of one of the forms of L'Hopital's rule. L'Hopital's rule says the following. Okay, it says suppose that f and g are continuous on AB and differentiable on the open interval AB. And let's let C be a point inside the interval. If C is a point inside the interval AB with the following two properties. With the limit as x approaches C of f of x being equal to 0. The limit as x approaches C of g of x equals 0. So in other words, f and g are both going to 0 as x approaches C, with the catch that g of x is not equal to 0 on AB minus C, and likewise for g prime not equal to 0 on that set. So g prime is not equal to 0 on that set. We just want to make sure there's no zero denominator issues, right? So with g prime g not equal to 0 on AB minus the point C, and likewise g prime of x not equal to 0 on AB minus C. Okay? In other words, we're going to avoid issues where I can have a whole bunch of zeros in the denominator. I wanted to just take it out of the equation. Suppose, so L'Hopital's rule says, suppose that the limit as x goes to C of f prime of x over g prime of x is equal to L, then, according to L'Hopital's rule, then the limit as x approaches C of f of x over g of x also approaches L. Okay, so even though they're both going to, like a 0 over 0, which is the typical L'Hopital thing, I still have that the limit of f of x over g of x goes to L. So let's see how we're going to do this. So, by assumption, by this assumption over here, I'm going to do this from, I'll do this argument from the left, and we can replicate the argument on the right by the same exact reasoning. So let's let epsilon be greater than 0, and pick delta greater than 0, such that if C minus delta is less than x is less than C, so we're approaching C from the left, we have that f prime of x over g prime of x minus L is less than epsilon. Okay? And so now what I'd like to do is I'd like to find a sequence of points. Let me fix a value. So let me fix x bar in this interval over here, in the interval C minus delta to C. And then I'm going to choose a sequence, pick a sequence, xn, and xn is going to reside in the interval from x bar to C. Okay? With xn converging to C. Okay? Good. So now by the generalized, by the Cauchy Mean Value Theorem, there are points what? There are points that are in between x, between xn and C, between xn and x bar. There are points which we call them xcn, which are between xn and C, such that what? Such that f prime of xcn times g of what? G of xn minus g of x is equal to g prime of xcn times what? Times f of xn minus f of x bar. And that should be a bar, of course, bar. Good. And now, what do I know? I know that these Cn reside between C minus delta and C, so I can say what? I can do this division over here, and I know that g of xn minus g of x is not equal to 0, right? So there's not going to be a vanishing over here. So what will I have over here? So I'm going to have that, if I do the division, that f prime of Cn over g prime of Cn is equal to this ratio, g of xn minus g of x bar, with the x go on top now, right? So we'll put the f of x on top. So then we have the f of x on top, f of xn minus f of x bar, all over g of xn minus g of x bar, right? And now I can subtract what from both sides? I can subtract off this L from both sides. So I'm going to subtract off an L over here. So I have an L over here. I can subtract off the L from that side. I can subtract off the L over here, and I'll get the exact same thing, right? And so now what happens as n goes to infinity? As n goes to infinity, this expression over here is going to what? This expression can be made arbitrarily small, right? So in this particular range, I know that this over here is stuck between what? This is going to be less than epsilon, right? So what I have over here is I have that this expression over here is also going to be less than epsilon. And for n sufficiently large, this converges to what? That converges to 0, and this converges to 0 because of the assumption that as you go to C, they go to 0. So what this tells me is this tells me that as n goes to infinity, in this sequence, we have the inequality that negative epsilon is less than f x bar over g x bar minus L less than epsilon, and that exactly says that the limit as x, and where does this x bar reside? This x bar resides in this interval over here. So in other words, we've just shown that if x bar is, for every epsilon there's a delta, such that if x bar is in that range, f of x bar over g of x bar minus L can be made arbitrarily small, but made less than epsilon in absolute value. So in other words, I don't even need this, right? We can just say this is true, right? And so this implies what? So this implies that f of x over g of x converges to what? Converges to L as x approaches C, and that's the proof of L'Hopital's rule. Thank you very much.